Introduction to IAM Trust Policies and Permission Boundaries. Welcome to our deep dive into AWS IAM Trust Policies and Permission Boundaries. Today we're going to break down these complex security concepts into simple, understandable terms. Think of IAM as the security guard system for your AWS account. Trust policies are like checking someone's ID for entry, while permission boundaries are like setting up rope barriers that limit where they can go once inside. We'll cover practical AWS CLI commands throughout this presentation, explaining exactly what each parameter does and what you can expect to see returned. What are IAM trust policies? Let me start with a simple analogy. Imagine your AWS account is like a secure building. Trust policies are essentially the security checkpoint at the entrance. They decide who can even attempt to enter and assume a role. A trust policy is a JSON document that defines which entities, users, services, or other AWS accounts are allowed to assume a specific IAM role. It's the first line of defense. The key thing to understand is that trust policies answer the question, who can wear this security badge, while permission policies answer, what can someone with this badge actually do? Trust policies are attached to IAM roles, not users or groups. This is crucial to remember. Now let's break down the anatomy of a trust policy. Every trust policy has several key components that work together. The principle is like the guest list at an exclusive party. It specifies exactly who is allowed in. This could be specific AWS accounts, IAM users, or even AWS services like EC2 or Lambda. The action in trust policies is almost always STS assume role. This is the AWS security token service action that allows someone to put on the role. You might also see condition blocks that add extra requirements, like only assume this role if you're connecting from our office IP address or only during business hours. Creating your first trust policy. Let's get hands-on. I'll show you how to create a trust policy using the AWS CLI. This is where the rubber meets the road. First, we'll create a simple trust policy document. I always recommend starting with a local JSON file. It's easier to edit and version control than trying to write JSON inline in commands. The AWS IAM create role command we'll use has several important parameters. The role name is self-explanatory, but assume role policy document is where we specify our trust policy. When you run this command successfully, AWS returns a JSON response with details about the newly created role, including its ARN, which you'll use to reference it later. Trust policy examples in action. Let me show you some real-world trust policy examples. These are patterns you will use constantly in production environments. Cross-account access is very common. Imagine you have a development account and a production account. You might want developers to be able to assume roles in production for deployment purposes. Service-based trust policies are equally important. When you want an EC2 instance to access S.3, you create a role that EC2 can assume, rather than embedding credentials in your application code. External ID conditions are crucial for third-party integrations. They prevent the confused deputy problem where a service might be tricked into performing actions on the wrong account. Introduction to permission boundaries. Now let's shift gears to permission boundaries. This is where things get really interesting from a security perspective. Think of permission boundaries like the maximum speed limit on a highway. Even if your car can go 200 miles per hour, representing your permission policies, the speed limit, the permission boundary, caps you at 65 miles per hour. Permission boundaries are an advanced IAM feature that sets the maximum permissions an entity can have. They don't grant permissions, they only limit them. This is incredibly powerful for delegation scenarios. For example, you can give someone permission to create IAM users and roles, but ensure they can never create anything more powerful than what you've defined in the boundary. How permission boundaries work. Permission boundaries work through what we call effective permissions. It's like having two keys needed to open a door. An entity needs both permission in their identity-based policy and permission in their boundary policy to perform an action. If either policy says no, the action is denied. This creates a beautiful security model for delegation. I can give you permission to create IAM users, but with a boundary that ensures those users can never access billing information or delete production resources. The boundary acts as a safety net. Even if someone accidentally grants overly broad permissions, the boundary prevents those permissions from being effective. Creating permission boundaries. Let's create a permission boundary step by step. I'll show you the complete AWS CLI workflow. First, we create a policy that defines the maximum permissions. This looks just like a regular IAM policy. It has the same JSON structure, same actions and resources. The AWS IAM create policy command will return a policy ARN that we'll use when attaching the boundary to users or roles. Notice how we use the path parameter. This is a great way to organize your policies. I recommend using paths like /boundaries/ to clearly identify permission boundary policies. Attaching permission boundaries. Now we come to the crucial step, actually attaching the permission boundary to an entity. This is where the boundary takes effect. You can attach boundaries to both users and roles. The syntax is slightly different, but the concept is the same. When you attach a boundary to a user using "put user permissions boundary", that user's effective permissions become the intersection of their policies and the boundary. The boundary ARN must be for a customer-managed policy. You can't use AWS managed policies as boundaries. This gives you complete control over the boundary definition. Real-world permission boundary example. Let me show you a practical scenario that demonstrates the power of permission boundaries. Imagine you're a team lead who needs to delegate IAM management to junior developers, but you want to ensure they can't accidentally grant themselves administrator access or access sensitive resources. This developer boundary policy allows typical development activities, like managing EC2 instances and S.3 buckets, but explicitly denies access to billing, user management, and production resources. The beauty is that even if a developer accidentally attaches the administrator access policy to themselves, the boundary prevents it from taking effect. Combining trust policies and boundaries. Here is where things get really powerful. Combining trust policies and permission boundaries in a comprehensive security strategy. The trust policy controls who can assume the role, while the permission boundary controls the maximum permissions they can have once they have assumed it. This creates multiple layers of security. Even if someone compromises the trust relationship, they are still constrained by the boundary. In enterprise environments, this pattern allows for secure delegation where different teams can manage their own resources without risking the security of the overall AWS account. Advanced trust policy patterns. Let's explore some advanced trust policy patterns that you'll encounter in real-world scenarios. Time-based conditions are incredibly useful for temporary access. You can create roles that only work during business hours or for specific time periods. IP-based restrictions ensure that roles can only be assumed from specific network locations, which is great for hybrid cloud scenarios where you want to ensure access only comes from your corporate network. MFA requirements add an extra layer of security, requiring multi-factor authentication before role assumption. This is essential for privileged roles. Now let's talk about troubleshooting common issues, because honestly, IAM can be tricky, and you're bound to run into them. The most common problem is the access denied error when trying to assume a role. This usually means either the trust policy doesn't allow your entity, or you don't have the STS assume role permission. With permission boundaries, a common confusion is thinking the boundary actually grants permissions. Remember, it only limits them. You need both the boundary and regular policies to allow an action. AWS CloudTrail is your best friend for debugging IAM issues. Every assume role attempt and permission check is logged there. Before we wrap up, let me show you one of the most underutilized tools in AWS. This is the IAM Policy Simulator. The simulator lets you test permission scenarios without actually performing the actions. This is invaluable for understanding how trust policies and boundaries interact. You can simulate different principals trying to assume roles. test the effect of permission boundaries, and even test condition logic. While there's a web interface, you can also use it via CLI with the Simulate Principal Policy command, which we'll explore. Best practices and security considerations. Let's wrap up with essential best practices that will keep your AWS environment secure and manageable. Always follow the principle of least privilege. Grant only the minimum permissions necessary. Permission boundaries help enforce this even when delegating authority. Use descriptive names and tags for your policies and roles. Future you and your teammates will thank you when you're troubleshooting at 2 a.m. Regularly audit your trust relationships. Use Access Analyzer to identify unused roles and overly permissive trust policies. Implement logging and monitoring for all role assumptions. Unusual patterns in role usage can indicate compromised credentials or insider threats.